Inteno has experience with the connected home for over a decade by producing and delivering gateways to internet service providers, mainly for the Nordics region. And about 5 years ago, a little bit more, Inteno decided to create an open software platform, a software platform that was built on open software, mainly on OpenWRT. And at the same time, in that area, we already were used to using our smartphones and downloading, installing apps and doing nice things with it, and everybody found it very convenient and easy to use. Looking at OpenWRT, many of those tools are available in there. So let's say I want to enable a smart home application. I dive in there, start typing around, fetching the necessary packages, do the necessary configuration, and hey presto, I have myself a working smart home solution. Now, for the average user, this is not that convenient. For the average user, it's going to be a little bit more of a problem. And this is what we try to solve with Inteno. We connected the OpenWRT environment to a backend cloud, which then manages those packages and all of these necessary configurations as a service that will then be used on the box. And this allows then the end user to just click on his smart app that will be using the smart home solution, and he sees a progress bar, and in the back end the cloud is requested to provide the necessary services on the connected devices of his account. He sees the progress, everything is installed and configured properly. Once the bar is done, he can start using his smart home application with no effort at all. For ISPs, story doesn't really end at that point. There you also need to add the necessary management interface, and you also need to have an additional help desk solution that helps the internet service provider troubleshoot these types of applications that you launch in the field. That is basically what Inteno has done with their open platform. If you want to talk a little bit more about this, we're available, and there's kind of many guys from Inteno here actually to talk about some details on either OpenWRT, how we did that, or the cloud part. Thank you.
Here, can you see your one out?
This one at the bottom.
The bottom?
Mm-hmm.
Perfect. There's your clicker.
Thanks. So hi, my name is Paul Blay. I'm part of the Creator team at Imagination Technologies. So Creator is a program aimed mainly at making development on IoT easier. And the reason why I'm talking to you today at an OpenWRT conference is because, well, for our latest kit, we chose OpenWRT to be the operating system on the gateway. But more importantly, we think that open collaborative operating systems, like OpenWRT and LEAD, are going to be core for IoT development in future. So this is our kit, which we'll be demoing at the back of the hall. At the top there in purple is the CI40, which is the gateway running OpenWRT. It's got 3 radios on it, a 6-low-pan Wi-Fi and Bluetooth low energy. And of course, it's MIPS-based. The darker devices on the right are the constrained devices, and both of these platforms have a microbus interface, which you can use to plug in these clickers, which are in green. There are hundreds of these clicks, and they're basically sensors and controllers. And so you know, whatever wacky idea you have for IoT, you can use these to develop that. So talking more about the software, we've developed what we've called the Let Me Create libraries, and this is an abstraction layer basically over the drivers. It's portable between both the gateway and the constrained device. And the sort of effect it can have on the work you need to do to get something up and running, for example, with the clicks, is we've taken this from some of the work we've actually done before Let Me Create was there and afterwards. it's almost a factor of 10 smaller. So it just makes life a bit easier for the people developing IoT on this platform. So on a larger scale, we've been working on an IoT framework as well, and we really wanted it to be open source and free. So the first part to this IoT framework is what we're calling our LWN2M stack. So this, as you can see, is LWN2M compliant, or is an LWN2M specification stack available on GitHub. Use Ipso objects with it, or magic up your own and manage them with this stack. It works both on the gateway and on the constrained device. So we needed, as a second part, we needed something for the cloud. So we came up with the Created Device Server. And what we really wanted from this was it to be portable across current, popular cloud providers. So at the back end of this, we have a REST API, which means you can plug it in to whichever provider you choose or want to work with, or you can host it locally, and of course it talks LWN2M with the devices. So this is an example of everything playing nicely together. If you can imagine your cloud app on the right, talking via REST API to the Created Device Server, and that talks through the IoT hub to the edge device, and then the edge device is using Let Me Create to make its life a bit simpler. Oh, God. We've got some projects. You're at the back. We're wearing these T-shirts. Come and talk to us at lunch. Thank you.
Next up, we have Jan.
Do you have some timer here, or I will rather.
No, but
Nice. Okay. Hi, so my name is Jan Čermák. Sorry to disappoint you if you are expecting Tomáš Hlaváček, who's written on the program. He couldn't come. But I will still talk about booting and running OpenWRT from BTRFS. So first, we have to introduce this. We have some beefy device. It's open. It's Turris Omnia. It's running dual-core ARM processor. It has 1 or 2 gigabytes of RAM, and it has eMMC flash. So it's not like other routers that those usually have some SPI flash. So we had need for some better file system than some JFFS2 or something like that. So we have decided for BTRFS. BTRFS has some good things. It's SSD friendly, it has snapshots and subvolumes, and it's quite performant. It has also some bad things. There are occasional bugs. Fortunately, it's getting better at the latest kernels. Also, we encountered the problem that we have to create the file system on the device itself, because there are some problems when the flash wasn't trimmed, and etc., etc. And it has slightly worse behavior on Parallels than some embedded friendly or embedded ready file systems. How we did it? So we had to add support for BTRFS to U-boot. It was ported from SysLinux. So now we have read-only support in U-boot. We can boot from different snapshots. We also had to add some hacks to the kernel to force reliable writes, because it's some mode of in the JEDEC standard that makes it more reliable or whatnot. So it was the only thing we had to change in the kernel, and also we wanted to add the support in the build root, but we encountered the problem I mentioned earlier, that we had to build the file system on the device itself. So we just had to add the support to the rescue image. That's some small kernel running from second flash on the device. We have something called Schnapps. It's not alcohol, it's a simple shell script about 500 lines long. It's like some abstraction layer for the BTRFS standard commands, so you can restore snapshots, list snapshots, rollback snapshots, etc. And the last thing, what we can do with it, We have automatic snapshots before updates. My colleague will talk about it later. You can do a rollback by holding a button, so it boots into the rescue image and does a rollback. And we also have the factory defaults image as a snapshot. So that's it. If you're interested, get in touch later.
So let's go. This one?
Yes.
Okay, no, hang on, I don't know why it's doing. Okay, this is, sorry.
Hope it doesn't count.
No. Okay, I have too many things open. Sorry.
No problem. Thanks. Okay, so my name is Beda Košata. I'm from CZNIC, and I will be talking about Turis Omnia, my colleague before me mentioned. I wanted to do a full-length presentation about crowdsourcing hardware, what does it take to run a crowdsourcing campaign and so on, but I had to cut it down to lightning talk, so just a brief overview of what I am talking about. We have done the campaign on Indiegogo for Turis Omnia last year, at the end of last year. In 2 months, we were able to gather something above $800,000. We let the campaign run. It runs until today, and we have more than $1 million already. We have sold, because the campaign you don't really sell, but it's kind of selling, more than 4,000 routers. As almost every crowdsourcing campaign, we are slightly late, but we are already shipping our routers, so that's nice. So now just a few things about the campaign, what we learned. The pros, what is good when you go to Indiegogo or Kickstarter and offer your product in such a campaign. You get publicity. That's great. It really helps you to spread the word and so on. Also, you get proof that there is some interest in your product. This was one of the most important reasons for us why we did it. We wanted to know before we start the production that there is an interest in open source, high power, secure router. And what is both a pro and a con, it's that you get external pressure from the people. They ask you every week, so how is it going? Is there any news? And so on. So you have to push harder to really do it. The cons are the same. You have the customers way long before you have the product. So you have all the cons of having customers and they asking you about the stuff and so on, way long before you are actually able to sell it or to ship the product. So this is a con. It can drain a lot of work, a lot of people resources from your team when you have to deal with it. Also the support for the people billing, payment tracking and so on. It can really take a lot from you. So just on time. So if you would like to do such a campaign or ask anything, just find me here. I am wearing such a nice t-shirt, so you will find me very easily. Thank you.
Good morning. My name is Arturo Rinaldi. I work as software engineer for Arduino SRL. This is my task briefly, especially mainly maintaining the Ladino distro for our internet boards and not plain toolchain and cross-platform and kernel drivers and question and answer as support for Ladino mostly. So maybe you've heard the word Ladino, this custom operating system we did for our boards. OpenWRT we know is unleashes the possibilities of the small office home office routers. So we think of it like an ecosystem, make open hardware, modules, open software layer, embedded environment. We'll see that at the end, open cloud system, and people, of course, giving us the every smallest contribution. So this is what we designed it. Core, MPU core, and MCU, which are separate but interact with them in a seamless way. And this is the Ladino approach, having us the MCU devices mapped as regular Linux devices with a particular version of with a custom firmware and some dedicated kernel drivers. So together with Nordic, we did interesting work with Arduino Tien and Arduino Primo boards with the Bluetooth stack, of course. We did some sort of IoT6 low pandemon involving two Arduino Primo boards and Arduino Tien. The Tien acts as IPv6 router, and the Arduino Primo acts as co-op, client, and server accordingly. If you want to find any documentation information, please point your browser here. Then another simple experiment I made, Bluetooth audio on Tien with Pulse Audio, and with the Bluetooth chipset on board of the Tien. This is a simple list of instructions I used, which are the common Bluetooth commands for connecting to Pulse, the Bluetooth speaker to, a Bluetooth dongle, and then the play with the PIA Play tool from Pulse Audio, and then the full set of compilers, the plain one, which is residing in the current repository, and then the cross-compiled Aware toolchain with the use of Canadian cross-compilation for building the firmware on our boards and flash straight into the MCU. This for the Aware family of boards, and then also for the ARM family of our boards. So basically you have a complete embedded environment size system on your boards. And thank you, I made it in time. Yeah, thank you.
So,
Wow, beautiful. So how do I turn pages? This one? That sounds easy. Good morning. I'm the last speaker this morning, so thanks for waiting for me. René Dubois. I'm going to show you a very simple example of using a WRT for something you can use every day at your desk. Transform your natural keyboard into a Bluetooth keyboard. So why do I do that? When I sometimes sit at a desk, I know people travel a lot today, but sometimes you sit at your desk, maybe you have a good computer, a good keyboard, and if you have to use your phone for, I don't know, checking how much time you still have or something like that, so you have to use both hands, one to hold it, one to type, and that's very inconvenient. You do a lot of mistakes, that's slow. So why not use your normal keyboard? In this case, it's a handmade keyboard, but it works with any keyboard. It's especially convenient when your phone is charging. You have a cable, and then you can put it on the stand. Okay? Now, what do you need in order to do that, or at least how did I do it? So Raspberry Pi, but you could use another board, power supply, SD memory card, Bluetooth dongle, and don't forget a small stand, a small holder for your phone. It makes it much more convenient. Now, how do you use it? Simply SSH, Telnet is a bit old-fashioned, SSH to the Raspberry Pi. You must have paired the dongle one time before, yeah? 3 minutes, I can't discuss that. You have a simple program that you run in a Windows called BTKBDEMU. Don't worry for the text, it's just debugging text to show you that it's doing something. And you type, it navigates your phone. I will have a demo running on later on, so please stop by and I will show you live. F12 to terminate, it reminds you on each line. So it's a very simple OpenWRT configuration. The Raspberry Pi is defined there, so just specify it. For Bluetooth, you need BlueZ utils, BlueZ libs. Import the module. I have a GitHub page with detailed instructions, so just build the module inside, make, flash, and it should work. Now, how does the program work? It's a console program. It just reads the STD in raw mode, reformats the data, creates a suitable Bluetooth package, and sends it to your device. Pretty simple. Another nice feature, it works, of course, on Macintosh, Windows. It would work on Linux. You don't need it on Linux. You can run the program natively, but it would work on Linux as well. What else? Okay, future improvements, I could handle the mouse. I don't at the moment. I'm not a big user of, not a big fan of mice anyway. Yeah, if you run on Windows, on the desktop system, some of the keys are handled by the desktop, so you cannot have them for your program, like Alt-Tab, for example, you can't do it. I think that's more or less it. Thank you. Some notes about pairing that I will not comment, and my GitHub if you are interested in the project. Thanks a lot. It was 3 minutes.
Very good, thank you. I'd like to share with you some of the data we just published as a result of a global survey we did on smart home security. So this is the first global study ever run across the industry. And quickly I'm going to walk you through 19 slides, so let's see what we can do. The findings. So IoT in the home is happening, and we'll see some data. It's not secure at all, and we will see why. And eventually we'll see some shift in consumer attitude with regard to security in the smart home. So this is what we did, 1,200 people across 6 countries, representative of 3 continents. So we have Japan, France, continental Europe, UK, and US, equal distribution across gender and age. So first findings, it's happening. And so if you look at the bar graph on the left, you'll see that 60% of the households already have 3 or more smart home connected devices. So this is not for the future, it's happening today. What are the most common devices? Game console, wireless printer, which is a main security issue and concern there, and smart TVs. And if you want to see the whole list, check out the report, it's available online. Some more surprises. So who's leading the innovation in this space? Continental Europe. So France leading with Italy and Germany, and Japan actually not doing much, 1 device per household on average. So very interesting, unexpected findings here. Let's get into the security, right? So we asked, how often do you upgrade the firmware of your router? And a good half of the people say, what router, what firmware, what? So that's a big concern, very relevant, by the way, to many people in this audience. Anything you can do to make seamless and more easy, really, to upgrade devices, that's definitely in the right direction. This is one of the few geographic analysis I'm going to share with you because I don't have time, but everything is in the report. So you will see that actually France and Germany are better at upgrading their routers, and Britons or UK not really so good, okay? Very good. So what do they do when they try to secure their devices? And again, the home gateway being the central hub or the firewall in the end for anything you connect at home. Well, 37% actually change the password, the default password, the one that you can find with Google if you just Google for the model. Half of the people don't even know what they can do, and a very small fraction actually does anything more than changing password. Let's skip this one. So we asked how many ports you have open on your firewall, and you see 29% said, what firewall, what ports? Yeah, okay. Only 7% had 0 ports open, which should actually be the norm for a regular use in the home, but you don't expose services to the outside internet. Consumers want more security, and they are actually willing to take responsibility for it and pay more for a more secure device.
All right. Well, thank you all the great lightning talks. We have lunch is actually right in the back. We have lunch until 12:35, so don't hesitate and enjoy lunch, and we'll be back here with the next sessions at 12:35. Thanks.